Hi everyone, my name is Indira Baburi. Today I am going to demonstrate the AP properties, that is the availability and partition tolerance in Riak database. For this I am going to launch 5 EC2 instances to form a Riak cluster for testing. Let's see how that is done. Now I am at my AWS management console. I have logged in. So let's go to EC2. I am going to launch 3 instances in one subnet and 2 more in other subnet. So I am using the security group that I have created before. These are the ports that are required for the Riak for internode communication and HTTP protocol and other things. So I'm going to launch. I have downloaded this key pair already. Let me launch 2 more instances. I'm going to use the same security group. If I have to use a different security group, I have to allow communication between these security groups. So for now, I'm using the same security group. Okay. So for the IPs to not change when we restart the instances, I'm going to allocate elastic IPs. Let's let me show how that is done for one IP address. So I'm going to attach an instance, private IP, even if we don't give it, will assign automatically. So this is how it is attached. Let me assign to all 5 of the EC2 instances and come back. So I have allocated elastic IPs to the 5 of the instances, and I've named the instances as node 1 to 5. Let's SSH into these EC2 instances. Let's install Riak dependencies into these instances. So I'm installing Riak now. These are the instructions I got from the Riak site for Ubuntu. So before starting Riak, we need to change some configurations to allow the intercommunication between these Riak nodes. So the config file is present here. So let me replace the local host by the private IP address of the EC2 instance. Also, we need to change the Erlang distribution port range. We need to mention that we have given in the security group of the EC2, so that the ports won't be assigned outside of this range. I'm going to do the same for this EC2 instance. So let's start Riak on these machines. Now that the Riak is installed and launched on these nodes, I'm going to show how to join a cluster. So this I have selected this node as a coordinator. We can select any node for that matter. So now these two are joined in a cluster. We can check the cluster status. Yeah. So I'm going to SSH into remaining three nodes and do the same thing for the remaining three nodes and come back. So I have installed Riak on these three nodes and joined the cluster. Let's check the cluster status. Okay, so all three are up and running. All five are up and running. These four are still joining. Uh, they'll change in a while. So meanwhile, we can plan and commit these changes. That is this cluster changes. Okay. Yeah, so the status is changed. All are valid and all are up and running. So let's create a bucket type of subjects. We can do it on any node. It doesn't matter. So I have created a bucket of type subjects. So let's see how on Postman how the data will be replicated. So let's see the status of actually I haven't updated the node values from the EC2 instances. Let me do that. So I have updated the node environment from the EC2 instances. So let's see if they are available. Yes. It seems all five nodes are available. So before creating a key value pair, let me check the bucket properties. So the bucket properties here says that allow multiple writes true, and I'm interested in only these two. I'll tell you why. Last write wins false. So unlike MongoDB or Redis, Riak is not a master-slave architecture. All the nodes can read and write data, hence it's an AP system. To resolve conflicts from writes on different nodes, Riak uses bucket properties. So these two properties contribute to the resolution, how it's gonna resolve. So there are two types of resolution: timestamp based resolution and last write wins. For this demo, I'm going to use timestamp based resolution. The setup for that is uh, last write wins is false and allow multiple write as false. So by default, this is true for Riak installations for version 2.0 and greater. So let me update that value. I'm going to set the values, allow multiple write as false. Okay, so now that is done, let's check how the values will be, multiple writes will be. Sorry. So I'm going to post on node 1 in subjects types of bucket type of subjects that we have created, and buckets as CMPE281, and in lab 1 I'm putting this value. So let's query and let's see if they are replicated on other nodes. Yes, it seems they have replicated well. So now let's create a partition with IP tables and see how the data will behave. Uh, so I'm going to create a partition by blocking node 1 and 2 on node 4 and 5, and vice versa. That is node 4 and 5 on node 1 and 2. So the nodes are blocked. Let me create a new value. Let's say lab 2. Lab 2 from node 1 and send. So let's check the values. So on the other side of the partition, let's see if the values are replicated. It seems it doesn't because of the partition. So before removing the partition, let's try one other thing. So I'll put lab 3 with key value lab 3 from node 1, and I'll post it. And I'll post on other side of the partition to see which data will be taken. So lab 4, sorry, lab 3 only, but on the node 4 and 5, right? So send. So now I'll remove the partition. Okay. So let's check the values of the lab 1. Lab 2, lab 1 we have already checked. Lab 2. So it's from node 1. For node 2 also it's from node 1. For node 3 also it's from node 1. For node 4, yeah, it takes some time to sync up. So For node 4 also it's from node 1. For node 5 also it's from node 1. So once the partition is removed, we can see that the data is replicated on the nodes that are on the other side of the partition as well. So let's see for the lab 5 where we have updated different values from different partition. Lab 3, right? So it is getting value from node 4, not from node 1, even though we have kept on one side. So this is because I have kept a timestamp based resolution. Uh, as node 4 is updated later, the value that is updated later is going to be written on all the nodes. So let's check for all the nodes for the value. So they are all getting from node 4. Yeah. So this proves that all the time the nodes of the Riak are available. This proves that it's an AP system. And for resolution, there are different methods that they provide for consistency of the values. So that's all I have for today. Thank you.